Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from increasing and decreasing functions, right? So here we have to solve this problem and we have to find the intervals in which this function f of x, which is log of sine x, is increasing and decreasing, right? Where x belongs to the interval 0 to pi, right? So here we are given the function f of x, which is log of sine x, right? And x belongs to the interval 0 to pi, right? And we have to find the intervals in which this function f of x is increasing and decreasing, right? So let us first see the definition of increasing function and decreasing function in terms of derivatives. Now see, if we have a function, say y is equal to f of x, right? And this function is defined in some domain D, and this function is said to be increasing if the derivative is positive, right? It means dy over dx must be greater than 0 for the function to be increasing, right? Or we can also write it as f prime of x is greater than 0, right? And this function is said to be decreasing if the derivative is less than 0, or we can write f prime of x is less than 0, right? So this is the definition of increasing and decreasing function. So we are given the function f of x is equal to log of sine x. So let us first find out the derivative of f of x, right? So f prime of x is d by dx of log of sine x, right? So here we'll make use of the chain rule. So the derivative of log sine x with respect to x is 1 over sine x, and then we have the derivative of sine x due to the chain rule, right? So we have 1 over sine x, and the derivative of sine x is cosine x. So this is cos x over sine x, that is equal to cot x, right? So the derivative of this function, that is f prime of x, is cot of x. So the first step is to find out the derivative of f of x. Now we have to see the intervals in which this function is increasing or decreasing, right? So we have to find the intervals in which the derivative f prime of x is positive and f prime of x is negative, right? So here f prime of x is cot of x. Now let us take the help of trigonometry, right? So here we have the four quadrants. This is first, this is second, this is third, and this is fourth. So now here we have the angle 0, here we have pi by 2, and here we have pi. This is 3 pi by 2, and here we have 2 pi, right? Now see, from trigonometry we know that in the first quadrant all the trigonometric functions are positive, right? So here the cot function is positive, right? And in the second quadrant only the sine function is positive, right? And the remaining the four trigonometric functions are negative, right? So here we have sine and cosec function are positive, right? And it implies that the cot function is negative in the second quadrant, right? So the in the first quadrant we go from 0 to pi by 2, and when we go from 0 to pi by 2, then cot x is positive, right? And cot x is our derivative. So f prime of x is positive in the first quadrant, right? So f prime of x is greater than 0 in the first quadrant. It means when we take the interval 0 to pi by 2, right? So here the function is increasing in the first quadrant, that is from 0 to pi by 2, the function is said to be increasing. And in the second quadrant, the cot function is negative. So when x belongs to pi by 2 to pi, then the cot function is negative, right? So it implies that the derivative f prime of x is also negative, because cot x is equal to f prime of x, right? So it means the function is decreasing because the derivative is less than 0 or negative in this interval, that is pi by 2 to pi, right? So viewers, this function f of x is increasing in the first quadrant, that is from 0 to pi by 2, and decreasing in the second quadrant, that is pi by 2 to pi, right? Because in the first quadrant the cot function is positive, that is greater than 0, and in the second quadrant the cot function is negative, that is less than 0, right?